this lesson, we'll be talking about how we can use factoring to solve equations, which we've actually done a little bit of in the past, but we're going to be a little bit more thorough now. So the first thing I'm going to do is give you something called the zero product rule, and it basically says if product equals 0, then either piece equals 0. So the only way you can have two numbers multiply together to give you a 0 is if either of the numbers equals 0. So what does that mean in terms of our factoring? It means if we want to solve an equation by factoring, the very first thing we have to do is set one side to 0. So has to equal 0. Then we factor to get a product, and then we can set each factor to 0. So I'll show you how that works with a couple of examples. So in problem 1, solve the equation. I'm going to set one side to 0. And with factoring, I usually like to have a positive x squared. And so I'm going to make sure that that largest power, the x squared, is positive by taking everything on the right-hand side and moving that over. So I'm going to subtract the 11x and add the 24 to both sides. And that gives me x squared minus 11x plus 24 equals 0. So that was step 1. And then we're going to factor. There's no GCF. So I'm going to try to find two numbers that have a product of 24 and a sum of negative 8 times 3 is 24, and if they're both negative, they add up to negative 11. So that was step 2. I factored, and then I can set each factor equal to 0, x minus 8 equals 0, or x minus 3 equals 0, and we can solve by adding the 8 and then adding the 3. So this equation has two solutions, x equal 8 and x equal 3. And so that really is the general process. I'll show you a couple more examples. But the basic idea is one side has to equal 0, we factor, and then we set the factors to 0. So example 2, I'm going to subtract the 17w squared and the 6w from both sides. So now I am left with 3w to the third minus 17w squared minus 6w equal 0. So step 1, one side equals 0. Step 2 is factor. And in general, the first thing I should do is look for a GCF. And it looks like we can only take out the w, and then we've got 3w squared minus 17w minus 6 equals 0. Now I have a trinomial, 3 terms, so I could use that trial and error method, or I think this time actually I'll use the AC method. So 3 times negative 6 is negative 18. So I need to find two numbers with a product of negative 18 and a sum of negative 17. I actually think negative 18 and 1 will work. And so then what I'm going to do, copy down the first term, and instead of the negative 17w, I write negative 18w plus 1w plus 6. First two, I can pull out a 3w, and I'm left with w minus 6. And then, oh, this looks like it's not going to work. And actually, I see why. It looks like I made a mistake. So the reason I'm catching my mistake here is I have to have a w minus 6, and I don't. And that's when I noticed I copied it down wrong. It should have been a minus 6. Okay, so this is better now because, well, I can take out a 1, and then I've got w minus 6. All right, so back to my equation. We still have the GCF. We'll take that w minus 6, pull that out front, and now we're left with a 3w plus 1. And all of that equals 0. So we actually have 3 factors here, and so I'm going to set each of these factors equal to 0. That GCF w could equal 0, w minus 6 could equal 0, or 3w plus 1 could equal 0. Okay, so w equals 0, w equals 6, or with that third one, we would minus the 1, divide by 3, so w could equal negative 1/3. So make sure you set each of your factors equal to 0, including that GCF. All right, example 3. So we do have to set one side equal to 0, but before we can do that, we're actually going to have to multiply or FOIL these out. So first would be 5x squared, outer is 1x, inner 5x, last is 1. Or if I combine like terms, 5x squared plus 6x plus 1. And then on the other side, first is x squared, outer is 3x, inner is 2x, last is 6. So when we combine like terms, x squared plus 5x plus 6. All right, so I FOILed everything out, and now I'm ready to set one side to 0. I'm going to take everything on the right-hand side and subtract it and see what we get. So that gives me 4x squared plus 1x minus 5 equals 0. And finally, now that this thing equals 0, I'm going to try to factor. If I want to use the AC method, 4 times minus 5 is minus 20. So I need to find two numbers with a product of negative 20 and a sum of 1. And negative 4 and positive 5 should work. So copy down the first term. The middle term becomes a minus 4x plus 5x. And copy down the last term. I can take a 4x out of the first two, left with an x minus 1. I'll take a 5 out of the last two. Oh, that's good. Also left with an x minus 1. We can pull that x minus 1 out front, and we're left with a 4x plus 5. And so once again, I have to set those factors equal to 0. So x minus 1 could equal 0. That means x equals 1. Or 4x plus 5 could equal 0. So then we would minus the 5, divide by 4. And so it looks like we've got two answers, x equal 1 and x equal negative 5/4. I'd like to finish this lesson by showing you a couple of application problems that we can also solve by factoring. And so in this first one, we've got a right triangle. And if you printed out my lecture outline, I forgot to type in these expressions. This would be given to you. So we have a triangle. We're told one side is x, the other side is x plus 1, and that longest side, or hypotenuse, is x plus 2. And so we want to find the lengths of the sides of the right triangle shown. And so there's a relationship from geometry that we can use for this problem. If you have a right triangle with two legs, A and B, and hypotenuse C, then we have a theorem, the Pythagorean theorem, which says if you take a squared plus b squared, you will always get the hypotenuse c squared. And so this is an important formula from geometry. You do need to know this formula. And we can use that in the problem given. So the hypotenuse, the c, is the longest side. It's the x plus 2. So our equation is going to be x squared plus x plus 1 squared equals x plus 2 squared. And then we can solve this equation using the process we talked about earlier. So we have to set one side to 0, but before we can do that, I need to FOIL everything out. So I've got an x squared, and then x plus 1 squared. That x plus 1 squared is actually x plus 1 times x plus 1. And so we do have to FOIL that out. Although you might remember there's a pattern that comes up here. When you take something and you square it, you'll always get the first thing squared. And then you can take that number 1 and double it. 1 times 2 is 2, so you'll get a 2x. And then 1 squared is 1. I wrote out in blue over to the side all of the work. Where does that answer come from? It comes from my foiling it out. So the same is true with the x plus 2 squared. I should get an x squared. And then I take 2 and I double it. That's 4x. And 2 squared is 4. I have the work written in purple for that one. So combine like terms. Now I've got 2x squared plus 2x plus 1 equals x squared plus 4x plus 4. And then I'm going to set one side to 0. So I'm going to subtract everything on the right-hand side to move it over. And that's going to give me 1x squared minus 2x minus 3 equals 0. The 2x squared minus 1x squared just becomes a 1x squared. So we can factor this. There's no GCF. Product of 3 has to be 3 times 1. If I make it a minus 3 and a plus 1, that does add up to negative 2. Oops. And then to finish, I can set each of these factors equal to 0. So the first factor, x minus 3 equals 0. So x is 3. Or x plus 1 equals 0. So x is negative 1. All right, to finish the problem, we want to find the length of each side of this triangle. And so that negative solution doesn't make any sense. We're not going to have a triangle with negative sides, so I can just cross that one out. So one of the sides must be 3. So I'll just say side 1 is 3. So then the second side would be x plus 1, so 4. And then that third side, x plus 2, would be 5. So the sides of this triangle have to be 3, 4, and 5. Let's do one more application. This problem says a ball is thrown upward and its height in feet, t seconds after it's thrown, is given by the following equation. H equals negative 16t squared plus 48t. When will the ball be at a height of 32 feet? This problem is basically asking us to find t, that's the when the height is 32. So I'm going to plug 32 in for h. So I've got 32 equals negative 16t squared plus 48t. And then I can try to solve this. I think factoring is easiest if your t squared or your x squared is positive. So I'm going to move the 16t squared over to the other side by adding it. So I'm taking everything on the right and moving it over to the left. All right, so that gives me 16t squared minus 48t plus 32 equals 0. So one side equals 0. Now we can try to factor. And I'm going to see if there's a GCF. And in fact, we can actually take that 16 out. And then we're left with t squared minus 3t plus 2. That's now a little bit easier to factor. I need a product of 2, so it's got to be 2 and 1. And if they're both negative, that's a sum of negative 3. And so now I'm going to set the factors equal to 0. That GCF 16 cannot equal 0. There's no t in the GCF. So in this case, the GCF doesn't give us a solution. 16 will never equal 0. But t minus 2 equals 0 when t equals 2. And t minus 1 equals 0 when t equals 1. So we've got two solutions here. The ball will be at a height of 32 feet at 1 second and 2 seconds. And the reason we have two solutions is if the ball goes up and then down, it must be at that height of 32 once on the way up and then again on the way down. All right, part B is asking us when, so find t again, will the ball hit the ground? And the ground is going to be a height of 0. So we're going to plug in 0 for h and then try to solve. All right, one side already equals 0. So we can try to factor. If you don't like that negative, which I usually like the t squares to be positive, you could take those terms and just move them to the other side. That would then give you a plus 16t squared minus 48t equals 0. And that might look a little bit nicer for some of you. You don't have to do that. All right, so then to factor, is there a GCF? Oh yeah, we can take out the 16. And we can take out the t as well. And we'll be left with t minus 3. So then I'm going to set the factors to 0. 16t could equal 0. And so that means t equals 0. Or t minus 3 equals 0. So t equals 3. So this tells me the ball is at the ground at 2 different times. It must be at the ground when it starts, and then it's hitting the ground after 3 seconds. And so when will the ball hit the ground? They're asking for the second time after it's been thrown. So it's going to hit the ground 3 seconds after it was thrown. All right, that is it for this video. Please send me a message if something's unclear. I'd be more than happy to meet with you.